Right, so thanks for the introduction, Laurel. And so I'm going to be talking about the work that we've been doing together on the relationship between gesture and language in aphasia today. And so here's the CME information for those of you who need it. I will also display this slide again after the talk is over so that you will have access to the code. So the learning objectives for what I'm going to talk about today are, what you can take away from this talk is the ability to define the term multimodal communication, list at least one factor that affects the relationship between gesture and naming in post-stroke aphasia, and also identify at least one EEG component that reflects semantic processing across gesture and language. So when we communicate, especially in face-to-face contexts like this, we use more than just speech, right? So you are hopefully getting some information additionally from the hand, well, maybe not the hand gestures that I'm using now, but I can use hand gestures to convey additional information and facial expressions in addition to just using my words to communicate information. And so the term multimodal communication describes the many ways in which we use our bodies and our surrounding environments to communicate in a manner that is beyond speech. For today's talk, I'm going to focus on the integration of hand gestures and speech within multimodal communication. So it's particularly important to consider the multimodal nature of communication when you think about rehabilitation for individuals with aphasia. So there's different approaches to aphasia therapy, which I'm sure many of you are at least somewhat familiar with, and they vary in terms of the extent to which they incorporate nonverbal modes of communication. Okay, so for example, constraint, I'm not sure if you can see the cursor.
Yeah.
Okay. Constraint-induced aphasia therapy forces patients to use speech only as a way of communicating. It's kind of similar to the constraint-based approach that you might see in sort of motor rehabilitation. Conversely, as the name suggests, multimodality aphasia therapy allows patients to use multiple modes of communication in addition to speech, like gestures with their hands, in order to get the message across. So we have these main approaches, and we also just know more broadly in the aphasia literature that there is sort of mixed findings on the extent to which the observation or production of meaningful gestures is helpful for language in individuals with aphasia. So there's not really of these therapy approaches. Neither one has really emerged as the one-size-fits-all treatment that works really, really well for all individuals with aphasia. And so for this, and also just theoretical interests, these studies discussed in this talk are attempting to identify factors which influence the connection between language and gesture in individuals with aphasia. And so one factor that's really important to consider is the high co-occurrence between aphasia and limb apraxia. So limb apraxia is characterized by difficulty performing skilled actions, difficulty producing and recognizing gestures with your hands, and about half of the individuals with aphasia following a stroke have limb apraxia as well. And so when we think about the multimodal nature of communication, particularly with regard to aphasia, it's important to think about this intersection between these two conditions. And to really understand this intersection between language and gesture, we need to consider the brain. So language and action rely on a broadly overlapping network of regions in the left hemisphere, consisting of a dorsal route that is more about sort of directly mapping between sensory input and motor output, whether that be via speech or using your hands. And then there's a more ventral route that taps into semantic representation. So in other words, this is the way that we represent meaning and our long-term knowledge about the world around us. So to give you an idea of what I mean by semantics, let's consider how your mind represents the concept of a hammer. Okay, so some of the concept consists of what a hammer looks like, for example. You also have an idea of what a hammer feels like and how you need to shape your hand and move your arm in order to successfully use a hammer. And then there's semantic information, which isn't a direct property of the hammer that you sort of glean through association. So other objects that might be associated with the hammer, like a nail, and context in which you use the hammer, such as the workshop pictured here. Of particular interest for the studies that I'm presenting today is the idea of action semantics. So in this particular example, referring to the ways in which you go about using the hammer. So for the studies at hand, we're defining action semantics as semantic information about actions that is accessible to language and during the execution, observation, and mental simulation of action events. And in particular, the studies I'm presenting today focus on the role of posterior temporal lobes and the role that they play in the representation of action semantics across both language and the action systems. And so our proposed existence of a shared semantic repository in this region has significant implications, not only for our scientific understanding of how language and action are instantiated in the brain, but also for rehabilitating language in individuals who've sustained damage to this critical left hemisphere network. So I'm going to begin by discussing an ongoing study about the relationship between co-speech gesture and naming in individuals with post-stroke aphasia. And then I'm going to discuss a newer study inspired by this work that investigates the relationship between gesture and comprehension in primary progressive aphasia. So this first study on post-stroke aphasia I'm conducting in collaboration with many colleagues here at MRI, as well as University College London and University of Pennsylvania. For this study, we are focusing on anomia, which is a naming deficit. So the difficulty that many individuals with aphasia experience with producing the appropriate name for items, such as objects in the environment. And we're also looking at how that is affected by the observation of co-speech gestures. And so, as I alluded to previously, there's some mixed findings in the literature about whether or not individuals with aphasia benefit from the observation of meaningful co-speech gestures. And so let me give you some examples of what I mean by meaningful co-speech gestures. Okay, these are gestures that we are using in the experiment. This is my colleague Isabel Chick from University College London. I see something in the chat. Okay, sorry. I just wanted to make sure someone didn't have a question on Zoom. And so this is the gesture that we are using to represent the concept of climbing. And then the concept of an object like snake, for example. Here's the gesture that we used. So this gives you an idea of what co-speech, meaningful co-speech gestures kind of look like. They evoke some of the action-related or visual aspects of the concepts that are being referenced. And so our hypothesis for the current study, based on the prior literature, is that we expect any observed benefit to naming from this meaningful gesture observation to vary with the individual's semantic abilities and with their praxis abilities, so their ability to, perform skilled actions with their hands or gestures. Given the ongoing nature of this study and that the praxis measures require some additional, more skilled coding that requires more training, I'm going to be talking about preliminary data focusing on the semantic ability aspect of our hypotheses for today's talk. So for this study, for the current sample that we're looking at, the preliminary sample, we have 29 participants with mild to moderate aphasia. The study is being run both here at MRI by me and also at University College London. And it is worth noting, although this is preliminary data, our sample is largely male and does demonstrate relatively mild aphasia overall. And so future research would benefit from more balanced or representative sample in terms of gender disparity. So I just want to qualify with that. And so we had participants complete a background battery of assessments, including the object and action naming battery, to kind of get an idea of the severity of their naming deficits. This is a confrontation naming task where participants are shown a picture and asked to produce a name of the object or action depicted. We also use the Western Aphasia Battery Revised to assess aphasia severity. And the synonymy triplets test was used to assess semantic ability. In this case, the ability to map words onto meaning. So in the synonymy triplets task, participants are presented with 3 words and they're asked to select which two of the three are most similar. Okay, so if you're presented with these three words, you should select violin and fiddle because they are more similar to each other than clarinet, for example. So our primary measure of interest, though, was a Go Fish game, which maybe some of you have played in childhood, but in case you don't remember, let me just refresh you on the goal of the game and the rules. So the aim of Go Fish is to collect matching pairs of cards. And so this requires the players to take turns requesting cards from one another. On half of the trials in our study, the researcher used meaningful co-speech gestures alongside their requests. And on the other half of the trials, the researcher did not use gestures when making these requests. And so the primary outcome measure of interest is the participants' naming accuracy in trials, well, in conditions both, with and without the meaningful co-speech gesture, but we were interested specifically in trials where the researcher had already requested the card that the participant was now requesting. So where they had, in the case of the meaningful gesture condition, the opportunity to observe a meaningful co-speech gesture, and we wanted to examine whether that benefited their future naming for that item. So just, I have to do a couple of things so you can hear the sound on this video. And it's still not muted. You have to like hold it in or? What's that?
You can just mute it on it.
On this. That. Why am I getting feedback? Oh. It is. Do you have a saddle?
No.
Rainy.
You have a belt.
I do not have a belt. No belt. Go fish. Okay, so I know it was a little bit echoey, but the idea is, right, that we're hopefully that illustrated somewhat the idea that we're taking these turns with the cards, and the participant has an opportunity to produce a name and also to respond to requests appropriately. And this was from the meaningful gestures condition, so you got to see a couple more, a little bit more how we align the meaningful gestures with the naming requests that we're giving the participants. Okay, so for this Go Fish game, we created individualized decks of playing cards using the pictures from the objects and actions in the object and action naming battery. And we made the decks based on their performance on the battery. So we balanced across the conditions with and without meaningful co-speech gestures in terms of the number of objects versus actions that were present in the deck used for the round of Go Fish. Also in terms of the number of errors versus correct items and the error type. So given that we expected the benefit of observing meaningful gestures to vary across individuals with aphasia, we decided to break that down by individual. So the x-axis represents individual participant IDs. And then we created a gesture observation benefit index, which is just a comparison of naming accuracy across the conditions where they observed the meaningful co-speech gestures versus where they did not observe those gestures. And as you can see, there are some individuals who show a pretty positive effect of observing the meaningful gestures on their naming accuracy for Go Fish. And some individuals who actually seem to show a sort of detrimental effect of the observation of these co-speech gestures on their naming. And so we wanted to see if this variation mapped onto anything meaningful. So we examined whether the gesture benefit observation benefit index could be predicted by some of the background measures that we collected, for example, of semantic ability. And so we found a positive relationship between their performance on the synonymy triplets test and their gesture observation benefit. So you'll recall that that's the test where they select, which two of the three words presented are the most similar. And it assesses their ability to map semantic meaning to word form. And so the better they performed on this test, the more their naming benefited from observing meaningful co-speech gestures. So this is preliminary data. And given that the effect is present but not super strong, we want to conduct additional analyses to evaluate how robust it is. But tentatively, what we're suggesting, in a preliminary way, is that this aligns with our hypotheses of shared semantic representation across language and gesture, right? So you observe a meaningful gesture, and for those with intact semantic ability, this enhances semantic activation and then facilitates their naming subsequently. So since this project is ongoing, there's quite a bit that we are in the process of analyzing and coding. So one of the next steps is to investigate whether praxis ability, as I mentioned before, moderates the benefit of meaningful gestures on naming accuracy. So you can imagine perhaps that observing meaningful gestures won't be as beneficial for you if you struggle with gestures yourself. Additionally, evaluating whether naming accuracy is improved when a person with aphasia produces gestures themselves, so not just observing meaningful gestures, but does gesture production benefit their naming behavior? And then additionally, we want to conduct lesion analysis to identify which brain regions correspond to the connection between meaningful gestures and naming in persons with aphasia. So maybe it's the case that this relationship depends on where the lesion is located across different individuals with aphasia. And maybe that the lesion analysis will also help explain some of these behavioral differences that we observe in the different profiles of individuals. So now I'd like to discuss a newer study that examines the relationship between gesture and language in primary progressive aphasia. And this is inspired by the project ongoing in post-stroke aphasia. I'm conducting, this project in collaboration with Dr. Buxbaum here, and then also with Dr. Kozlet, an undergraduate at RA Kristen Lee, and Dr. Wagner from FedChem. So primary progressive aphasia, or PPA, it's a neurodegenerative disease, and it's characterized by substantial language dysfunction that occurs early in the disease progression. There are different variants of PPA, and they tend to be characterized by different patterns of linguistic impairment that correspond to neurodegeneration that begins in different regions. So with the semantic variant, as the name suggests, is characterized by deficits in semantic knowledge across modalities, so not necessarily just limited to language. And in this variant, we see atrophy begin in anterior and inferior temporal lobe areas. For the non-fluent agrammatic variant, as the name suggests, it's characterized by deficits in grammar and the presence of speech apraxia, so more motoric issues with speech in this variant. Atrophy tends to begin in the posterior frontoinsular regions. And then finally, the logopenic variant is characterized by impaired verbal repetition and phonological speech errors. And atrophy for this variant tends to begin in parietal and left posterior perisylvian areas. So despite the variation that we observe across the variants, verb comprehension has been observed, verb comprehension impairment rather, has been observed across the different variants of PPA. But the underlying cause of these deficits remains a bit unclear. And so to think about potential explanations, we consider verb deficits in other populations. So there's some evidence for impaired verb comprehension in Parkinson's disease and ALS. So these are other neurodegenerative conditions that are more characterized by prominent motor deficits. And so some of the frameworks that have been developed to explain these verb deficits in these diseases involve the disruption of sensory motor stimulation. So since these diseases tend to impact more frontal motor regions or the frontal striatal circuit, the argument here is that if you were trying to, comprehend or retrieve the concept of waving, and you have difficulty sort of simulating that for yourself on a sensory motor level, that this would impair your linguistic ability to retrieve or comprehend waving. Not everybody is a fan of this hypothesis. An alternative explanation actually involves the syntactic complexity of verbs. So they tend to be more central to sentence structure. Therefore, they're a bit more difficult to comprehend and retrieve. And so the argument is that what we're actually seeing is some executive dysfunction due to disruption of these frontal areas. And that's the explanation for why we see the verb deficits here. So we can kind of think of the competing frameworks in the following way. So there's a syntactic account, which I just mentioned, right, which kind of argues that the verb deficits don't have anything to do with semantics. Verbs are more syntactically complex and harder to retrieve. Then there's the semantic account that I just mentioned, developed based on the Parkinson's and ALS literature, where there's this sort of impaired simulation component that is contributing to difficulty with verbs. And then there's the account that kind of draws more on some of the work that we've been doing in thinking about the dual route models of language and action, where you can have impaired action semantics, you can have impaired conceptual information, but you don't necessarily observe impaired sensory motor simulation. So when we think about action semantics and PPA, there isn't a ton of work that's been done on this topic, really. So Lebkuecher is common, similar to post-stroke aphasia in individuals with primary progressive aphasia across all of the variants. And Lebkuecher in the semantic variant in particular has been characterized by deficits in action knowledge. But like I mentioned, there just isn't that much work done on this topic. So the current study is examining action semantics and PPA using EEG, which has been widely used to investigate action semantics in other populations and just language and semantics more generally. And it's a useful tool given its high temporal resolution and that it doesn't inherently require participants to produce an overt behavioral response, which, as you can imagine, is an advantage when you're working with a population that has language dysfunction. So one EEG component of interest in particular for this study is the N400. So it is thought to index semantic processing because it is evoked in response to unrelated or unexpected stimuli. So in this graphic, borrowed from Van Elk and colleagues, you can see that at approximately 400 milliseconds, hence the name, there is a more negative going peak in neural activity for pairs of unrelated words compared to pairs of related words. And so we view this as a signature of semantic processing that the brain is able to differentiate matches versus mismatches and relations versus less related words. In addition to the N400, we are also interested in looking at the beta oscillation and mu rhythm. So these are neural oscillations that are generated by brain areas that tend to be involved in sensory motor processing and imagery. And a decrease in the amplitude of oscillations suggests that the corresponding areas are engaged. So we're interested in oscillations within the spectrum here for the current study and examining whether or not they provide evidence for any disruption in sensory motor processing. So the current study explores whether the presentation of related gestures facilitates comprehension of words in individuals with PPA. And we're looking at the N400 as an index of semantic processing, the sensitivity to whether the gesture and the word are related, and also examining the beta oscillation of mu rhythms for evidence of any sensory motor disruption of the presentation of gestures. Okay, so once again, these are our competing accounts. And so I wanted to talk about what we might expect to observe in terms of EEG components, depending on which account is the correct one for accounting for the verb comprehension deficits. So regardless of which account is correct, we expect to observe some behavioral evidence for the verb deficits based on the previous literature. However, in the syntactic account, while we would expect to see these deficits, we wouldn't expect to see any differences in N400 or beta and mu from neurotypical controls, because the argument is that semantics are not the issue, and sensory and motor disruption is not a problem according to this account either. For the semantic account that involves sensory motor stimulation, we would conversely expect a reduced or absent N400 to show difficulty with semantic processing in individuals. That is likely contributed to by a reduction in the desynchronization of beta and mu relative to neurotypical controls. So essentially evidence for some sensory motor disruption here, and evidence for semantic difficulties by a reduced or absent N400. And then conversely, the semantic account without sensory motor stimulation would predict that while beta and mu should be comparable to neurotypical controls, we should see a reduced or absent N400 since semantic processing is problematic. Actually, semantics are affected.
Maybe, sorry to interrupt, just for you to know your mouse is not tracking properly.
Oh,
It's not where you're pointing,
That's
where you
probably-
want to point
Okay.
for some reason. Just to let you know.
no, I appreciate that.
Okay.
It really isn't.
Yeah, that's okay.
Okay, sorry if that was confusing. Right, so for the current study, we are going to run a small sample since this is a pilot study of individuals with PPA with an approximately equal number of participants across the variants for comparison, and then 10 age-matched neurotypical individuals as a control for some baseline performance. So this is a diagram that illustrates just the basic structure of the task. So we have a video showing a gesture here, in this case, the gesture for drive, a brief pause, and then there will be an auditory presentation of a word that either matches, and I apologize because I'm relying on the arrow here, but the word is drives. The top box shows a match versus a mismatch. And so we want to examine whether participants are sensitive to that mismatch across the word and the gestural prime being presented. So to give you an idea of what we're interested in EEG wise, if there is intact sensory motor processing, we would expect, once there's the presentation of a gestural prime, to observe desynchronization of mu and beta. But more interestingly, I think, is examining the N400 effect or lack thereof after the presentation of the target word, right? So we would expect, if semantic processing were intact, that when the target does not match the prime, as in pinch here, you would see a more negative going with peak neural activity than when the target does match. Yes, Tim.
I was just trying to follow that. Sorry, yeah, your mouse was dripping up. So when they do the prime, the squiggles we see on the left, the mu and the beta rhythm, that's what we expect to see just with the presentation of that.
We expect to see like a decrease in the amplitude. It's basically kind of a suppression almost of those oscillations, suggest that the areas in sensory motor imagery are engaged.
And then that might be differential according to the group of participants, according to the type of your three groups might have. Are you expecting that in everyone?
No. I expect there to definitely be the group we're most likely to see it in the PPA would be the non-fluent variant, if we do see it at all, just because they are the ones that show some motor issues in their speech. But this is more just kind of differentiating whether there is the sensory motor disruption and if it then kind of contributes to any semantic disruptions that we see. But yeah, I don't anticipate that we're going to see disruptions to beta and mu across all participants. I think there will be individual differences or possibly not a disruption of beta or mu.
So the kind of criterion measure is this N400 that you're looking at, and the differentiation according to the targets.
Yeah, so the N400 is of particular interest, right, in demonstrating that this is an issue with semantics, and then determining whether there's a sort of potential role for sensory motor simulation. That's what beta and mu adds to the story.
Thanks for clarifying.
Yep.
Make sure I understand. So if I understand correctly, you think that the verb processing is related to like more broad sensory motor processing? Is that what you said?
So I actually don't. So there's basically, this kind of ties into the review of action semantics that Laurel and Branch and I have been doing. And basically what we've come across is that when you look at action semantics, the theoretical framework that has been developed to explain the deficit varies depending on the population that you're looking at. So, you know, there's action semantics, as we've discussed it in left hemisphere, like through Laurel's work, left hemisphere stroke, and similar theories have been adopted for PPA, though, as I mentioned, action semantics isn't looked at as much in PPA. And then there's the Parkinson's and ALS literature, where when they're looking at this verb processing, they're proposing that there's this sensory motor simulation component to it that is being disrupted by the neurodegeneration. And they argue that that is what accounts for observed verb deficits.
Okay, so my question, I guess, is in this population, do they have actual sensory motor processing problems or deficits?
So
Like, would you, because if that's the hypothesis, I would expect to see a relationship between behavioral presentation and sensory motor processing problems and not just at the EEG levels one might fit. But do they have motor processes?
yeah, so I mean, the only so the motor problems that we see in the non-fluent variant seem, at least my understanding of literature, is that it's speech apraxia, it's motor issues related to speech, but they don't have the prominent motor deficits that we observe in these other populations like Parkinson's and ALS. And generally, honestly, part of what you're asking is a bit of an open question. Yeah, we don't really know the extent to which there's the disruption of sensory motor processing in this population. So it could be the case that there isn't, and if there is, I anticipate that the non-fluent variant would be where we see it. Yeah. Yes, and so, right. To get at behavioral evidence for these deficits, right, we also have, we're looking in a separate prime target test so that it doesn't interfere with EEG recording. We're having participants, you know, it's essentially the same task, except that participants are being asked to reply yes or no via button press, whether the target and prime match up. And through this, we'll evaluate their response time and their accuracy to look for behavioral deficits of that we were interested in. And so as a kind of secondary aim, we're also interested in how these effects might vary across the individual, since a lot of this, as I mentioned, is pretty exploratory. There's not a lot of research done in this domain. And based on some of the work that we're conducting in post-stroke aphasia, we're interested in how, you know, semantic ability and praxis might play into this relationship between gesture and language that we see. And so we are also running participants through a background battery of measures that include those of semantic and praxis ability. But that's, you know, more on that later, essentially. Those are kind of more exploratory aims. So overall, the take home, I would say, from these studies is that they shed light on the relationship between gesture and semantics. And this has important implications for example, the dual route models of language and action in the brain. So how we think about how these two capacities are related and instantiated on a neural level. But ultimately, we do need more research to understand this overlap between gesture and language. And this is particularly true in PPA because there is very, very little research looking at the connection there. So thanks to everyone for your attention. And then here's the CME information again for those who did.
That was a great thought. So that I had more of a big picture. My head is still stuck on the flashlight. This might be a very nice question. You had two extremes of aphasia treatment options. One being the constraint-induced aphasia therapy, and the other being multimodal communication-based treatment. I'm always trying to draw parallels from the motor domain because that's what I'm familiar with. So in the motor domain, the constraint-induced movement therapy is more helpful for the lighter patients who have some volitional movement. Whereas the other extreme would be more helpful for the more severe patients, but it almost felt, I don't even know if that applies for the aphasia domain, but if that is true, it almost feels like the data you presented was from the more milder group of patients, if I'm not wrong. So I wasn't sure if how that matched or how to even if the parallel.
Yeah, so it is, I think I forgot to mention on the slide where I showed the relationship with semantic ability. Yeah, this was despite aphasia severity and naming deficit severity even, which is interesting. Because I also anticipated that severity would be a factor here, right? Where, I mean, and granted, I think it might come into play, right? Where you can imagine that if an individual has more severe aphasia, alongside of some of these other impairments that we think are key, you know, like the impaired semantic ability, potentially, I can't speak to this yet, but impaired praxis, that then having the additional gestural information might just present another source of noise that they have to sort through. So I can anticipate that being potentially more of an issue for more severe patients. But yeah, it is interesting. I can't really speak to severity directly based on our data, which was a little bit surprising. But maybe with the, you know, as we continue, maybe we'll have more answers.
So I'm not really familiar with EEG, so I just wanted to ask more about that 10-400. Are you anticipating seeing that in the controls and not seeing it in the PPA individuals? So they would have that semantic ability to diminish.
Right. Yeah, so that's one of the things that's almost a little counterintuitive about some of the EEG effects, right? Is like we expect to see the N400 in individuals with the intact SNP. So it's kind of like we're looking for this effect, but if we don't see it, that's when we can conclude that there is impaired semantic processing. Yeah, so it's a little bit hard to say exactly. I feel relatively confident that at least the semantic variant individuals will show a reduced or completely absent N400 effect. And I anticipate this could be true for the other variants of PPA, but it's a little bit less serious. But yeah, I definitely expect the neurotypicals, provided that my experiment is well designed, to show that N400 effect in responses to a mismatching priming target. Yeah. Yes.
Correlation between, so for post-stroke hemiplegia, as you start to recover motor function, is there, and if you have both aphasia and hemiplegia, as like in physical therapy, if you start to regain function in your motor function, is there also a correlation increase in aphasia?
I think I know what you're saying, and the answer is I do not know offhand the answer to that question. Yeah, because hemiparesis, so many of our participants do have hemiparesis, and we are keeping track of whether or not they have that. We haven't looked at it yet. And yeah, it's a little bit different from so when we think about limbopraxia, for example, right, this is not like a lower level motor issue. This is a higher level issue with action. So unfortunately, I don't have a good answer for your question. It's a really interesting thought though.
So, first off, going to the first study, I do really enjoy how the task paradigm is easy to implement in like any lab, because that makes it real nice to repeat studies. You did the testing for all this, right?
At this site, yeah.
Yes.
And Shauna helped me with some of the sessions.
Gotcha. For when doing the gesture condition, did you look at the time for word retrieval, or did you look at like ease of retrieval from if they were doing the gesture condition versus?
I would love to. Yes. So it is something that we're considering. It requires, because of the nature, like the recording, and because it is unclear exactly, given the sort of gamified nature of the task, exactly when we should consider like the onset versus the naming.
Gotcha.
Timing is, I think there's a lot there. We just are working on exactly how to get at it.
Okay.
Because I think there's a huge difference between like, do you have a dog and do you have I can't think of dog, you know, that's to me, current accuracy wise, that would be coded the same. But yeah, so I would like to look into that.
And then, follow-up question, did you notice a difference in like frustration between the two different groups? Or like, was one a little easier for one group than the other, or was it just mixed?
That varied based on participant, to be
Okay.
honest with you. Because we had some individuals who, you know, and granted, we only looked at the gesture observation with this particular data. But what's interesting is there's also variation in how much individuals wanted to use gesture themselves.
Gotcha.
So we had some people who just didn't really seem to use gesture, and then we had others who we had to repeatedly remind during the note. Because we also, I should mention, when we weren't using gestures, we also did not allow them to use gestures as well during
Gotcha.
that round on the Go Fish task.
Okay.
And so, yeah, the individuals who really seemed to want to use gesture did find that constraint a little bit frustrating. Yeah.
Yeah, I was just wondering why, like, your neuroanatomical and neurofunctional hypotheses are mostly focused on the posterior temporal cortex. Like, to me, like, the semantics network is much larger than this part of the brain. So, yeah, I was wondering why this part of the brain and not like especially for your prediction about the lesion symptom mapping analysis. Are you expecting only to find like a link between the behavior and the lesion only in this part of the brain, or are you expecting to find it in different part of the brain as
Yeah,
well?
I'm not only expecting. So I do think that the posterior temporal area is a critical area of overlap between the language and action models. And I do think it is particularly key as we, you know, for representation of action semantics. But yeah, the network is certainly distributed and there's many areas of overlap between the two models. So
when you say action semantic would be something that is only movement related without any lexical information, right?
So so I would argue that it's not only movement related, right? So our definition of action semantics, we argue that it's also semantic information that is accessed during language to describe action. But yeah, I was thinking of things like, you know, hand shape when you're using a tool, for example, as being an example of action semantic information that would be represented there.
Okay. And yeah, okay, because I'm thinking like yeah, all this we chat sometime during our lab meeting about that, like more like the embodied cognition theory. So that's basically if you present like a verb that is evoking an action with the hand or with the foot, that gonna like maybe involve different parts of the brain that are related to sensory motor processing of foot and movement. So it's more like a view that is let's say modality dependent of like for semantic processing. And I was like thinking also, even though it only is not, you're not expecting only the PTC to be activated, but I was wondering like if you consider also like the PTC like something that could be a model in the sense that you have like semantic representation that's not gonna depend totally of the modality. Or
I mean, with regard to action concepts, I would anticipate that there is a modal, right? So the visual and kinesthetic information for the action semantics in the posterior temporal areas. Yeah, so I don't think that area is a modal, if that's what you're asking.
Okay.
You want me to jump in?
Yeah, sure.
So, I mean, there are a lot of fMRI studies that show that when people look at hands and they look at tools, you get activation of that posterior temporal region, even when no action is planned. So still, that doesn't speak to whether you get implicit activation of some kind of sensory motor information when you're looking at those hands and tools. But I agree that the semantic representations are distributed. And the question is, what's going on in that particular part of the brain? might be much more linked to visual information. What does an action look like? Makes sense, right?
Mhm.
It overlaps and is very closely adjacent to the regions of the brain that activate when people see moving bodies and hands, but not necessarily when they plan movements themselves. So it's still an open question. I think one thing that's really unclear here when it comes to the PPA predictions, and we haven't really talked through them all very carefully, is the question about what does M1 contribute? What does primary motor cortex contribute to semantics? There's certainly a number of studies that show that you do get homotopic representation of different kinds of actions along M1, right? This is all like Mueller's most
Right.
famous work about that.
His life.
So when you process verbs like to kick, you get a different part of M1 activation than when you process to grab.
Right, right.
So that has been argued for one extreme position coming from the Parkinson's and the other, ALS literature,
Right.
is that is that is semantic activation that you're seeing in M1. So there's been a bit of reductionism.
Mhm.
Most of us think that that's not semantics.
Right.
That's not all of that, might be a part of the representation, but it's distributed and you have a lot of the cortex, not even just in the left hemisphere, talking to each other. And so I think really what this study aims to shed light on is, do we see differences in patterns of performance across the subtypes, right? In the gesture word priming aspect and behavioral, right?
Right.
And do we see differences in either or the neural signatures of sensory motor processing on the one hand, or so-called semantic processing on the other? And I mean, I think that, as you pointed out, none of the subtypes of semantic dementia have primary motor deficits associated, limb motor deficits associated with them. They don't have hemiparesis, right? You get limb apraxia. But so I think the reason that the study is quite exploratory. Amy, if I'm not mistaken, nothing like this has been done with this population at all. So you are all raising really good questions, and I think it's really an exploratory,
Very much.
early days for this kind of work.
Yeah, very much so, very exploratory. Yeah.
And thank you very much for the talk. It was very interesting. I was just wondering, I mean, I first wanted to kind of applaud you for using a semi-naturalistic task in your first study. I think this is great. And I was actually wondering, what would be your predictions if you use like a, this well-controlled naming task with the same population? I mean, would you expect similar effects, or do you think, the social context that you're creating within the task, and does this help?
Really
And maybe, that's why you're seeing, more benefit or less benefit?
Yeah, no, that's a really good, I'm just gonna take a second to think about that,
Yeah.
because I hadn't thought about that before.
I know we've talked about the study, many, many times, but I was just thinking maybe there is something in the social interaction that's.
Yeah, I could imagine, I mean, this is purely speculatory on my part, but I mean, I do think that the multimodal nature of what we're doing is particularly fitting, given that we're using a naturalistic context, because when you're having a conversation, with people, it does feel a little bit more natural to sort of have, I mean, granted, we prescribed the gestures that we were using, right? But we tried to use them in a pretty naturalistic way that fits the game context. So yeah, it does beg the question where if you had a more artificial setting, would the observation of these gestures be equally helpful? Or would that artificiality kind of make it a little bit noisier and maybe a little bit less natural? Like, I don't know if I'm describing myself, but yeah, I think you're onto something there, and I think the benefit might be at least enhanced by the presence of this naturalistic context for sure. Yeah.
But the gestures are, I think, I don't fully understand. The gestures are meaningful. Do you know that does it matter what the gesture is? Like, is that pairing, does it have to match the word, or can it be just, can you set up in the beginning, this gesture means this? One thing that struck me is this snake.
Yeah.
I was like, oh, if you just did that, I was like, oh, that could be a fish, that could be a lot of.
Right, yeah.
So I'm just curious.
Yeah, so in this case, yeah, the gestures that we used in particular for this are definitely, yeah, because they could be evoking multiple concepts, right? They are constrained by the speech that is used alongside the gesture, right? So, yeah, so you're right. I showed you the videos of the gestures in isolation, which probably might have been a little bit misleading because as you saw during the video of the Go Fish game itself, I was using it alongside the word, right? So it would, snake climbing.
Yeah,
Would be,
so
yeah.
I assume you spent time with the person before saying like, this is the gesture that goes with this word?
Nope.
Or do you just hope that they pick it up implicitly?
So we tested out the gesture. So there was a norming study conducted for the gestures themselves. And so participants online were presented with the gesture and the word and asked like, how well do they go together essentially? And so we have the gesture informativeness ratings and yeah, so there is variation, but they're reasonably high. And yeah, I mean, I'm sure, like I said, there's probably some that go better than others, but I didn't sense just anecdotally that the participants were sort of struggling. Yeah, but yeah, no, it's a very fair question. Yeah, because some of these gestures would be really hard to interpret out of context, for sure. Yep.
You have any other questions from trans? Great talk, really, really interesting work. I was thinking about the graph where you had the behavioral assessment and some people benefiting from the gesture and some people not, there was no effect and some people getting worse. And I'm super curious about these people that get worse. Like, what is happening with that? Is it
So
and
this
it could be many different things that
Yeah.
come to mind, but maybe you have some insight into
Yeah, I
that.
mean, this is a bit of an open question still, since we're in the preliminary stages of it, but a few thoughts that I have are, so, for those who have lower semantic ability, right? So if you're kind of relying gesture as a different mode for priming that shared semantic representation, but you don't have a really good semantic representation to sort of be activated by that gesture, then maybe the gesture isn't really helping you so much. And that's why we see this relationship between the semantic ability on the synonymy triplets test and whether or not they benefit from the observation of these gestures. Another thought that I have, which I don't have data to speak to yet, is that if you are an individual who has limbopraxia or issues with gesture, then the gesture isn't necessarily providing you with additional information. And now it's this sort of source of visual noise almost that you have to integrate along with the auditory speech.
It would be interesting to look at like, well, so that's the benefit of the matching gesture. So do you see in the group that has that benefit that a mismatched gesture, like, do they show that makes their performance worse? Because that would support, because the distraction, the noise thing should affect people with intact and with impaired semantics.
So we don't have, for the post-stroke aphasia study, all of the gestures were matching, they were meaningful and matching to the concept that was being, to the word that was being requested. So it would be interesting though, but yeah, we didn't test them on mismatching gestures for that study.
Can I make one point of clarification also about limbopraxia, since there are really two major subtypes of limbopraxia. Of course, they vary along the continuum. And so when you talk about struggle with gestures or who have limbopraxia, that's actually a bit broad, right?
Right.
You're really talking about whether the ability to recognize gestures.
Yeah.
Which is really just one component. It's just like in aphasia where you have comprehension and you have production.
Right.
And you have some people who are more impaired at one than another. So people who have bad gesture comprehension shouldn't benefit from, right? And it might even be that in those people who have bad gesture comprehension, that having that additional information is might make them worse because it's sort of, they're
Yeah,
trying to attend to it, they're not really getting the meaning from
right.
it, it's distracting, it's a dual task
Right.
in a sense. So just you
yeah,
want
no,
to be
good,
very
good point of
specific.
clarification.
Yeah.
Thank you, yeah.
Yeah, I think I have two other questions kind of related to the discussion. So first
Mhm.
about the variability, I was wondering like if you were making the task more complex, especially to like selling effects and testing like controls, would you expect to observe like this type of individual differences with like some participant that looks like they have like control, I mean control, not typical control, they have like facilitation, or some of them that have like more like interference or inhibition?
So you mean if we took the Go Fish test? and
Yeah,
made
I
it
don't know
more
how
difficult?
exactly, but
Yeah, yeah.
because I guess
Just like
if you
a
test
jumping
control,
Done stuff like this when
Okay.
Anna was involved in a study where we got controls off ceiling by adding noise, auditory noise. So they couldn't really hear as well
Uh-huh.
and they couldn't process the meaning of the word verbally. And that way we could really look at the benefit or the decrement that accrued from having that additional semantic information, whether it matched or mismatched.
But you
Yeah.
also see like variability
In the controls, yes,
Yeah.
to get to your question, right?
Okay.
Yeah,
You know, like, for example, working memory.
right.
so like some interference as well, or
Well, I think the study.
Like a negative
actually
effect?
Memory, they do look at computers, but they show like correlation between motion and performance.
inability?
Correct, it was visual working memory, right, that they. I
Trying
think
to remember.
with the gestures.
I was.
But yeah, so, yeah, there is some individual variation in neurotypicals, is the take.
Yeah.
And we were talking about that yesterday, Monday, when we had Alfonso Caramatz's talk. We were talking about the continuum of variability that you see within controls
Right.
as well as in patients. So we would certainly expect there are some neurotypicals who benefit more than others.
Absolutely.
It would be very interesting to look too at whether that's related to anything interesting like their semantic ability.
Yeah, no, absolutely, definitely. I think individual variation in neurotypicals is, I mean, I guess it's kind of becoming a hot topic, but I think it's not studied as much as it should be.
Great, thank you.
Thank-